Okay, now let us give you some definitions that will be useful later in your studies. And we mainly want to talk about something called immersion, submanifold, and embedding. So first we want to talk about immersion. Immersion, let's say you have a map from M to N again. This is a smooth map, but this time let the dimension of M be equal or less than dimension of N. This is a constraint we are imposing. Then this map F is called an immersion of M into N if the push forward map is an injection. That means it's an injective map. Okay, now let's define something called embedding. This map F is called an embedding if F is an injection and immersion. So to qualify to be qualified for the embedding map, F has to be injective as well, and then the push forward mapping of the vectors is it also has to be injective. That's what immersion means, right? So you can think of it like this: you are mapping each and every point to another unique point, and at the same time you are mapping all the vectors on M, or so to say the tangent space of M, at every point to a unique vector on manifold N. Okay, now under this map F, the image that you get, that is you are mapping from M to N, and your image is what? F of M, which is just which can be all part of N or some part of N, and that image is called a submanifold. So the submanifold is that under this sort of a mapping, the image F of M is called a submanifold, and this image is defined in such a way that it is diffeomorphic to M. Now let's take a example that will clear these definitions for us. What do we mean by these things? But to describe the example, let's draw some figures first, and then I'll explain. This is figure, and this is another figure. This is again S1 R squared. Let's say this map is given by G, this map is given by F. So from this figure, what we can immediately conclude that F is not an immersion. Why? Because this is not an injection, because of this point over here. F is not an immersion. Oh, sorry. Sorry about that. Yeah, F is an immersion because immersion is a map on the tangent spaces. F is an immersion, but F is not an embedding because of this point over here. Because you can have this point and this point, or this point or that point, or any two points on the circle such that it's getting mapped to this point over here. So it's not an injection. However, the map over here, G, this is an embedding so G is an embedding because the map, the image so to say, doesn't intersect itself, so there is no multi-valuedness, it's an injection. And this is also an immersion. In fact, this map from the circle to this R square, whatever this figure is also a submanifold. So G of S1 is also a submanifold. And before we finish off, we want to say that an embedding is an immersion. So if you have an embedding, it's already an immersion. But the converse is not necessarily true. And you can also think of the idea of embedding in such a way that if you have a two sphere, that's a sphere in our three-dimensional space, you can always realize it in the 3D space, right? So S of 2 can be realized in R3 properly. S of 1 can be realized in R2, and in general S of n can be realized in R of n plus 1. So these are also examples of embedding. Now that we are done with these things, we'll turn our focus into flows and Lie derivatives.